In this lecture, I am going to present an example of how to compute the torsion capacity of a non-pre-stressed reinforced concrete beam. The cross-section of this beam is going to be 12 inches in width and 24 inches in depth. It has 8 number 6 rebar going longitudinally, distributed along the perimeter, and stirrups number 4 spaced at 6 inches on center. The compressive strength of the concrete is 3000 psi, and the yield stress of both the transverse and the longitudinal reinforcement is 60,000 psi. The first thing we're going to determine is the threshold torsion. As I have presented in previous lectures, the threshold torsion is the value that defines whether we need to explicitly design for torsion or not. This is the formula for threshold torsion, and the elements of this formula, first of all, is phi, which is 0.75 for torsion, F prime C, which is 3000 psi, ACP, which is the area of the cross section, and in this case that area is 12 times 24, 12 by 24, which results in 288 inches square, and PCP is the perimeter of that cross section, and that's 2 times 12 plus 2 times 24. 2 times 12 plus 2 times 24, and that results in 72 inches. We substitute in and we obtain a value of 47,323 pounds inches, which if we divide by 1,000 and then divide by 12, we get the value for threshold torsion of this cross section, which is 3.94 kip feet. We move on to determine the ultimate torsion capacity. This is the formula given by ACI, and I'm just going to go over the calculation of each one of the components of this formula. First, phi, again, equals to 0.75. AT, which is the area of one leg of transverse reinforcement, and that is 0.2 because we have number 4 at 6, and the area of one leg of reinforcement for a number 4, that area is 0.2 inches square. The yield stress is 60 ksi, and the angle theta at which we expect the cracks to develop is 45 degrees, which means that the cotangent of theta is 1. S is the spacing, and that's 6 inches as specified here, number 4 at 6. And then we are only left with A naught. How do we compute A naught? Well, A naught by definition is the area enclosed by the center line of the transverse reinforcement. In this case, we are going to have 2 inches of clear spacing to the longitudinal rebar. Since we have number 4 transverse reinforcement, that means that the center line of that reinforcement is 1.75 inches from the edge. Right? We basically subtract half of a half, which is 0.25 from 2. So that leaves us with 1.75 inches we have to take off from each side, and that results in 20.5 inches in the vertical direction and 8.5 in the horizontal direction, and we end up with a area enclosed here shown in gray, AOH, with the red font, that area there is calculated right here. So it's 8.5 times 20.5, that results in 200.5 inches square. If we multiply by 0.85, we get A naught equals to 169.9. We can substitute that into our formula here, along with all the other values that we determined, and we obtain a value for the ultimate torsion capacity equal to 509.7 kip inches. Take that to kip feet, dividing by 12, we get 42.47 kip feet. So in summary, a cross section shown here has a threshold torsion of 4.55 kip feet and an ultimate torsion capacity of 42.47. There is only one question left, which is, do we have enough longitudinal reinforcement to develop the full torsion capacity? We know from ACI that the formula for longitudinal reinforcement necessary is this one right here, and we are just going to go ahead and substitute in the values and see what amount of longitudinal reinforcement we get. If that reinforcement needed is less than the one that we have provided, then our section is satisfactory in terms of longitudinal reinforcement. So again, here is our formula for longitudinal reinforcement. We substitute in all the values. Area of one leg of transverse reinforcement, 0.2 inches square. The spacing of the transverse reinforcement, 6 inches. The perimeter of the center line of the transverse reinforcement. So again, we already have those values here from the previous calculation, and that's going to be basically 2 times 8.5 plus 2 times 20.5. Right? These are these values right here that give us the perimeter of the center line of the transverse reinforcement. 2 times 8.5 plus 2 times 20.5. That gives us a perimeter of 58 inches. 60 KSI for both longitudinal and transverse reinforcement. So this ratio here becomes 1, and theta being 45 degrees, cotangent of theta square is 1, and our final number for the required amount of longitudinal reinforcement is 1.93 inches square. If we compare that with the amount of reinforcement that we have actually provided, which is 4 rows of 2 number 6s, which is 8 number 6. The area of a number 6 is 0.44 inches square, so the amount that we have provided is 3.52 inches square, which is larger than the required amount, which is 1.93, which means that our section is okay in terms of the longitudinal reinforcement required to develop the full torsional capacity.